just blabbing on about stuff. So what this is, it's a tool that, a programming interface that the people from Dice.com created for developers who want to write tools that interface, who pull data from Dice.com, can use. And modern day, historically, the way these things worked, let me actually open up a keynote here. This is 200, right? Mm-hmm. So this kind of adds to a little bit of our history of computer science stuff. So historically, what would happen, this concept, I promise I'm typing. Would I go swimming with this too? Well, that works. What the heck? All right, let's close Keynote and reopen Keynote. Let's see if we have better luck this time. There we go. Apple products.
Did you forget to plug your keyboard in on your laptop?
You know, with the amount of sleep I had this weekend, I would have almost bought that had I not gotten a pretty good night's sleep last night. Anyways, we had this thing called an API. That's an abstract programming interface. Now, these things have existed forever. So whenever a company has a product that they want other people to be able to take advantage of, we can even think about this as hardware type stuff. They might create tools, whether it's an attachment or something like that, for other people's products to connect into it. Make sense? So historically, APIs were proprietary. Is that it? That's spelled right-ish?
Yeah, close enough.
So each place would make their own version of the API that follow its own rules and its own format and all this other crap. Now, that's all fine and dandy, but the problem is there's not a consistent way that people get used to working with APIs. Maybe more importantly, there isn't there does not exist a core set of tools for working with APIs because there isn't a standard format for APIs. Then there was invented, so for a long time you might have had something like, let's say you needed to represent data. You might have comma delimited lists. So if you ever use Excel and you have a whole bunch of crap in an Excel spreadsheet and you want to export it, you would export it maybe to a comma delimited list format. And that still exists today. So sometimes you'd pass data back and forth between the things, just comma delimited. Then we had a cool invention, and I'm sure everybody in here has heard of it, but probably few of you know what it is. Something called XML. Everybody in here has heard of XML? It's one of those computer science-y tech words that nobody really knows what it is. What can you tell me about XML? Surely someone in here has some factoids about XML. Randy, you stole his seat. It's garbage. Snooze, you lose. Why isn't anybody wearing purple? Purple. He's wearing purple. Green. Why isn't anybody wearing green?
No one remembered it was St. Patrick's Day.
How is that possible?
The school colors are blue.
People only celebrate the day before.
I was wearing green about an hour
The weekend. He's technically drinking out of a green can. That counts. He's technically drinking out of a green bottle. Just put it in a pocket. It's an accessory at that point. All right. So what do we know about XML? Go ahead.
You can define your own
Okay. So you've heard about XML before from me probably, right?
I work with it.
Oh, you work with it now?
Yeah.
Okay. So you just recently learned about it?
Yeah.
Okay. So XML stands for Extensible Markup Language. Now, just quickly, let's jump to a secondary slide here. Have we all heard of HTML? What is HTML? Hypertext Markup Language. This is what it stands for, but what is it? Making web page crap language?
Yeah.
Yes.
Okay, that guy? So, just to give you an idea what HTML looks like, if we were going to make a simple web page, we might have HTML. So there's our hello world version of HTML. Each of these guys is called a tag. So tags follow the syntax of a less than sign, followed by the tag name, followed by a greater than sign. And there's always a corresponding closing tag, which has the same thing with a slash in front of it. Okay? Now, some tags can have things inside of it, like, color is equal to blah or something like that. So you can have tags with additional variables inside of it, but let's just keep it simple for this explanation. So HTML existed before XML. Now, you may have seen something before listed as XHTML. Have you ever seen that? So XHTML is a XML compliant HTML document. And what does that mean? In the early days of HTML, and this almost goes back to this statement of proprietariness. So HTML came out in the early days of the internet. Very early days of the internet, when we first started having web browsers. This was back in the day when people actually used things called Gopher clients, which was one of the main tools of the internet. You had Gopher, you had FTP, you had Telnet, you had email, you had web. So in any case, it was very proprietary in nature because you had multiple companies all kind of using their own HTML-ish type of language. Now, why did HTML exist? HTML existed so that web browsers could display pretty pictures and text of web pages. So people had to write web pages, and web browsers had to be able to resolve those web pages. So the person, if you will, that that HTML was speaking to, that language was talking to, was a web browser. Web browsers took HTML as input, processed it, and spit it out to the screen as pretty pictures and text. Now, how many of you have ever experienced a web page that looks different on Internet Explorer versus Google Chrome versus Safari versus blah, 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 Firefox, all the time, right? One of the reasons for this is those web browsers have been around for a while, and they're backwards compatible with much older websites. Much older websites that lived in the proprietary years of HTML, or at least the less formal years of HTML, had to support bad HTML programming. That is, things like, I don't want to close this tag. Okay, we'll display it anyways. If any of you, how many of you have ever programmed in HTML? Several of you? How many of you have ever created a bulleted list in HTML with list items? Okay, this is going to be an interesting question. Those of you who rose your hand and said that you have written in HTML, do you think you wrote good HTML or bad HTML? And what's going to be funny is even if you used a tool, sometimes the tools spit out bad HTML. So if you're creating a list item, we'll create a unordered list. And then list items would be like blah, just whatever. We'll just do 3 of them. We'll do 3 blahs. Now this one will be cat. So bulleted list with 3 bullets, blah, blah, and cat. All right. Is this good HTML or bad HTML? Bad HTML. Why? We didn't close our list item tags. Now, when you guys created list items, did you close your list item tags?
Yeah.
Really? Did you do it on purpose, or did you use a tool that closed it for you? Oh. Now, I bet if you go to, next time you're on a website that has list items on it, and you right-click on it and say View Source, and you hunt through the website and find out where that list item is, probably 50% of the time, they will not have closed their list item. This was a very common example of loose HTML, where they did not close their list item tags. Because every web browser supported this. Every one of them. So the problem is that our web browsers today support this bastardized version of HTML as well as XHTML. Okay, in fact, I think there's a setting on most web browsers today whether or not you want to make them conform to XHTML. And if you do that, a lot of web pages won't show up correctly anymore. They'll just get all screwy. So in any case, HTML existed before XML. But this idea of XHTML was the HTML language defined by XML. So what XML is, it's a language, well here, let's call it this. Let's do tag-based language creation tool. So it's a tool that allows us to create our own languages with opening and closing tags and all that stuff. And more importantly, it tells us the definition of that language. So we can send that to the person who's going to be speaking to us in that language. So for instance, for web pages, the web developers are speaking HTML. Who are they talking to? The web browsers. Okay? Now, this is what HTML code looks like, but imagine like a bank or a doctor's office or something like that. Maybe they have a XML protocol dealing with their records. So maybe we have record patient name Mike, so on and so forth. Okay, so they can represent patient records or something like that using an XML language. They would define that language, and then and you don't even need to define the language, just create a tag-based representation of stuff like this. But by defining it, you've created a standard. So now you can send that data definition language to whoever is going to be using this, and they can say, oh, if I want to format patient records to send to this doctor's office, they must be formatted like this. And then their software can receive it and do the right magic with it. That makes sense? So that was XML. So XML was kind of our first standardized communication tool that many APIs adopted. You know, it started off as, hey, we like this concept of HTML, but because of misuse, HTML's kind of gone to crap. But let's take this idea of a tag-based language and let's create a standard around it. Okay, so for a while, XML was very popular. Today, XML has not been completely supplanted, but it's very quickly becoming the old technology. Anybody know what the new kid in the block is? That's a true statement, but not the answer to the question I'm asking. HTML5 is the latest version of the HTML language, which is XHTML compliant. HTML5 is really replacing Flash. Yeah, so for years, Flash was a problem. How many of you are Android users? Okay. How many of you have been Android users for, let's just call it a while, like 4 or 5 years? many of you been alive for 4? Like, I didn't have a phone 5 years. In the early days of Android commercials, one thing you may have remembered is Android used to brag about how they have Flash and iPhone does not. How many of your Android phones have Flash on it today? Who won that argument? So Apple was always anti-Flash, not because Flash is innately bad. Flash is fine in our laptops or our desktops, but the mobile version of Flash was very sluggish, so it didn't perform well, and it was a battery hog. So Apple went against the grain and said, we're not going to support Flash because they were the backer of HTML5. Well, one of the main backers. Apple didn't create HTML5, but they were a big proponent of that technology. HTML5 allows you to accomplish that kind of animation type stuff that Flash does. But it's a much more modern technology, not bandwidth, blah, blah, blah. All of your phones, iPhone, Android phones, whatever, they all support HTML5. Lightweight technology can pretty much capture everything that Flash could. And probably the first sign of the victory was when Adobe Flash Builder, the makers of Flash, had an export to HTML5 option inside the Flash Builder software. So, that's probably the first sign of the white flag. But in any case, the new kid on the block for data representation is a tool called Json. And it stands for something, I'm not sure what it stands for. But Json is a much more C programming language type of kind of visualization. With XML, there's kind of a lot of fluff, right? The real data here is my page and blah, blah, cat. Everything else is kind of filler, right? So what JSON attempted to do, so let's take this patient record version of JSON. So I'll just copy this. And let me just create a second text box just so I can copy it, then I'll delete the first one. So in JSON, we would have something like this. Well, let's here, let's just give you a first name equals Mike. So that would be the equivalent representation of JSON for it. JSON also supported arrays. We talked last class about tables. So JSON allowed us to support collections of data as well. So it was even a more powerful tool. And it was very C-like. So people who were writing the connectors for these APIs were talking. They were talking in a language they were already kind of familiar with. C programmers, Java programmers, Objective-C programmers, C# programmers, all of our modern day high-level programmers are all writing stuff that is, let's just call it curly brace based. Okay? They're going to be familiar with this kind of lingo. And just to give you a quick idea, I'll flash back here. Notice what this code here looks like. This is JSON. Pretty much looks like what I just showed you. Okay. Now, so JSON's kind of the new kid on the block. Does that mean XML is gone? No, I would say a lot of APIs currently allow you to request, do you want the information as XML or do you want it as JSON? There was an early standard for APIs based on XML called SOAP. So if you've ever talked to an API, you're ever in your future computer science career, you are asked to interact with an API and somebody calls it an old SOAP API, SOAP would be XML based. Okay? So SOAP followed an XML standard. I'll leave it on there, it's fine. So anyways, JSON's kind of our new kid on the block. everything we wrote here is just kind of an evolution of how do we represent data in a consistent way so that when we talk to Facebook's API, or we talk to Twitter's API, or we talk to Dice.com's API, we're passing information that's in the same format. The data within the information's the information's different, but the format's consistent. Does that make sense? So then we can create tools for working with those formats. We can create a generic tool for working with JSON. We can create a generic tool for working with XML, and then based on that tool, we could say, give me the value for patient record. Give me the value for patient first name, that kind of stuff. Okay? So that's kind of the world of these APIs. So at this hackathon that 3 of our sophomores and 2 of our seniors did this last weekend, we were using, so Dice.com historically had an API, was JSON based, but it was not what was called a RESTful API. So our new kid on the block for APIs, and this isn't data representation, this is how an API functions, is called a RESTful API. And what's interesting about RESTful APIs is they rely on a very old technology. When you talk to a web server, so the HTTP protocol, which talks to a web server, supports several functions. Every single time that we are using our web browser and we are typing something into the URL at the top, that's called a GET request. Well, here, let's just do this. Request types. That's a GET request. If you've ever filled in a web form or something like that on a web page and hit submit, and you see all your data listed in the URL, you know, first name equals Mike, last name equals Littman, all in the URL, it'll look something like, blah.com, question mark, F name is equal to Mike, and L name is equal to Littman, something along those lines. If you've ever seen something like that, it was submitted to the server as a GET request. Everything is packaged inside the URL. Then we have a POST request. That same information can be sent, it would look like blah.com, but behind the scenes, the first name and the last name were also sent as part of the body of the POST request. Okay, so get, post, delete, I think update's still one. Let's just say it's these 4. There's actually like 2 other ones, but get, post, and delete are the 3 standards. So most RESTfuls are based on those 3, or these 4. Get, post, delete, update. Actually, not update, it's put. That's what it is. Most RESTful APIs are based on these 4 functions, but there's a couple other ones. So because all web servers support these 4 things, and web servers have been around for a long time, people who build RESTful APIs, they've decided, let's leverage this old technology. Let's take this idea of a GET request and say, GET requests are how we get stuff from the data source. So if we did a GET, we would retrieve information from Dice.com. If we did a post, we were putting information into Dice.com. If we were doing a delete, we were removing information that was up in Dice.com from the server. If we did a put, we were updating information that was on Dice.com on the server. So we use these 4 different functions to determine what we are actually accomplishing, rather than having to build that into some sort of strange query that we were sending. Historically, APIs, we'd always use a GET request, 100% of the time. And we say, this is what we want to do. So in that GET request, you say, I want to add something. I want to delete something. I want to get this information. I want to update this information. You have to say what you wanted to do. Now, based on these 4 things, we can say what we're going to do based on which technology we're using, which port we're using. Okay? So we're only passing around JSON. If we say a GET, it's going to give us JSON. If we're saying post, we're going to give them JSON for them to store it. If we're saying a delete, we're going to give them some piece of information that we extracted from JSON probably an identifier, unique identifier for it. Put, we're going to give them a unique identifier as well as the JSON we want to update it to. Something like that. So RESTful APIs, which are the new kid on the block, are based on a very, 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 very old technology. Okay? So kind of interesting how things come around, right? And it's because the web servers have become standard. Whether there's really two standard web servers you see in existence today. You see Apache. Anybody who's running a Linux or Unix server for their web server is going to be Apache based. It's probably half the internet now and shrinking probably. I would say Linux or Unix probably represented about 90% of the internet 10 years ago. The other kid on the block is Microsoft, using something that they call IIS, Internet Information Server. That's their web server. So right now it's probably 50-50, IIS versus Apache. Okay? But both of those support these 4 HTTP protocol requests because the HTTP protocol came before Apache and IIS. All right? So RESTful APIs talk in terms of these 4 things. Now, having said all of that, one problem we run into is a lot of programmers, modern day programmers, this was kind of the problem that I tackled at the hackathon. Modern day programmers aren't aware of things like this. So a lot of the stuff that I just explained to you, people that have graduated in the last 5 or 6 years and are out there working professionally may not know. And it's not because they're stupid. It's because this technology that this is based on was very old. And it became antiquated. Well, not antiquated. It became hidden underneath power tools. You know, I deal with this all the time in our Java programming class. The old way of writing Java programs, you would be writing it in Notepad or something. You'd actually have to type in javac blah.java to compile it, then Java space whatever to run it. Now what do? You hit the play button. That runs it. So all that stuff's still happening behind the scenes, but nobody sees it anymore. So our modern day programmers are coming out, they don't know how to compile a Java program by hand because they've always used an IDE for doing it. Okay, so these people that have gotten into industry in the last 5, 6 years, something like that, even longer, they've never been exposed to having to work directly with a web server or directly with a lot of these technologies. It's always been abstracted from them, hidden from them because they're using more modern tools that make it simpler for us to work with. So they have forgotten or never learned about things that used to exist. So one issue we have today is this concept of a RESTful API, since it's based on older technology, things that probably somebody who graduated 10 years ago might not be familiar with. While it's a great idea, it's a cool use of old technology, and it's really a really good idea. A lot of modern day programmers don't understand this world, so it's difficult for them to work with RESTful APIs. Does that kind of make sense? All right, so what I ended up doing is I created a, this is specifically for iOS, for iPhone and Mac programming. Well, it's Objective-C based, so it's anything Macintosh or Apple based. But you could easily port it over to Java, I would assume. Is I took their RESTful API and I wrote an NSObject-based API on top of it. So I wrapped this new kid on the block that a lot of people don't understand with NSObject-based things that everybody who writes stuff for Apple understands. So NSObject to Apple, to Objective-C, would be like an actor is in GameSalad. We all know what actors are, right? Actors have attributes. We can attach behaviors to them, all that stuff. We know about those guys. So everybody who's writing software for an Apple product knows about NSObjects. So I created kind of a small API that wrapped Dice's RESTful API, and we had really 2 different things. we had collections of dice jobs, and we had dice jobs themselves. That's what dice is. It's get jobs. Okay? So that's our dice job object. Not important, not important, not important. So for example, getting all the dice jobs that exist in Milwaukee required these 2 lines of code. And this first one looks scary. This whole thing right here is just a universal password key that Dice gives you. It's just a string that says this uniquely identifies you on our server. Okay, so these 2 lines of code allow you to retrieve from Dice every single job that exists in Milwaukee as Dice objects. And then from there, if we have a Dice object, if we have a collection, how do we get an object? Well, you can get the object at position 5 in that collection. That gives you job at bucket 5. What if I want to get information about that job? Well, I can go and get a specific job, and then I can come in here, and out of those jobs, I can get the website, the job ID, the status, the notes, the pay rate, the area code, the job length, description, web URL, all these different pieces of information, but they don't have to remember about those pieces of information because I defined somewhere in here, do it in Dice collection. No, there. I defined a unique type. So in Game Salad, we have attributes. Our types of attributes are text, integer, angle, Boolean, things like that, right? I created my own type called a Dice object field name type. And these are all the different field names. These are all things that you can request from a Dice job. So if you are an Objective-C programmer, if you are a high-level modern-day programmer in whatever language, you're used to working with things like this. You're not used to working with things like this. These represent 2 separate worlds. Modernly, you have people that are considered to be webmasters, web programmers, and then you have people who are kind of common programmers, people who are writing software for iPhone or Android or desktop, that kind of stuff. Those people usually represent different skill sets. A lot of times the webmasters kind of have a hybrid skill set. They're part programmer, part designer. They can make things look pretty and they can, write enough code to function in, let's just call it less complex development worlds. That's kind of the web world. That doesn't mean it's easy, it just means it's kind of less complex. But they also have the added complexity of they need to make things look pretty. Where the traditional programmers, people who are writing stuff in these more complex languages like Objective-C or Java, they're usually not the ones in charge of making it look pretty. Okay? So, in any case, the tool that I created for this thing was a wrapper around the Restful API that allowed any Objective-C programmer to immediately start bringing in Dice jobs into their programs through 2 lines of code. So you can get every job that exists in Milwaukee with 2 lines of code inside of your iPhone program, for example. So that's kind of what I tackled for it, but it's an interesting thing related to our class. So, and chances are Dice, I don't know, they probably won't pay me for it, but we'll see. They're going to end up putting this API up on their website along with their new API, so people who are iPhone programmers can just download it and immediately start using it. So I contributed to the community or whatever. So that's kind of the API thing, but this gives you a kind of a history lesson of the world of APIs and how they've evolved and things like that. And we can see examples of these things over and over and over again in the world of computer science. How things evolved and sometimes things that used to exist become popular again, that kind of stuff. Isn't the same thing with fashion? Is that, I mean, I'm not fashionable, but is that like a true statement? Like bell bottoms were out, then they were back in, and now they're completely out, I think. And those socks that went up to your waist. Those existed, didn't they?
I still wear them.
You mean, I don't know. Maybe they're, knee-high socks, not waist. Knee-high socks. They're still cool? But are they still cool, or are those the weird people? They might be the weird people. Okay, so they're eclectic. That's the proper term. Okay, so that's a bunch of good news. Bad news. Midterm on Wednesday. What? Wednesday. You'll have them back on Friday. Because I think I have to have midterm grades turned in by Monday. So you'll know where you sit. So let's go back through our slides from earlier this semester and kind of talk about what will likely be on there. So I'll give you a kind of a thumbs up, thumbs down on whether I deem something to be important. So you kind of know what to focus on. The exam I will design to take about 30 minutes. So it should not be a time-sensitive issue. You'll probably find many people. I'm designing it for the average person to take about 30 minutes. If you are a fast test taker, you might see people done in 10 minutes. So I'm not designing it to be a very long exam. Okay. So certainly some of our introductory stuff, like what is programming and stuff like that, would certainly be important on the test. The types of languages. What is a language? Examples of programming languages, probably less important. I probably will not ask you to list 3 high-level languages or something like that. I care more about the broader concepts than the kind of those details. These would certainly be fair game, all these 3 different types of slides. So what are the 3 different types of programming languages? Machine language, low level, high level. And what is each one? Generalistic computer questions like what's a CPU? Fair game. Whether it makes an appearance on the test or not, we'll have to see. It probably would not be my first choice of a question, but if I need an extra question thrown in there, I might ask something related to it. So middle of the road in terms of the importance scale in my head. 2 types of programming languages. This one would be fair game, but I probably would not spend any time in here dealing with interpreted. I might ask you about compiled languages, maybe in the context of something else, but I would not focus very much on interpreted in here. So having said that, compiler translates the high-level language into a low-level language, that type of thing would be fair game. Functional, procedure, object-oriented languages. I will not ask you anything about functional languages, but procedural versus object-oriented, certainly fair game. Domain-specific versus general purpose. Important to know, probably won't ask you anything. I probably won't ask you to tell me what's the difference between a domain-specific and a general-purpose language. It's kind of too vague of a question, I guess. Definitely, I would be very surprised if this does not make the test in some way or another. How do human beings solve problems? Through memory, asking questions, and repetition. Two types of programming languages, loosely typed and strongly typed. Probably will not ask a question along those lines. It would be fair game. But I would not put it real high up there on the importance scale. So if I'm trying to keep the test to 30 minutes for most people, I would have to really run out of other questions to ask something about this. Java questions would be fair game. I probably would not waste a question asking, tell me where Java fits in the world. I would more than likely ask questions related to those parts. What's a object-oriented language versus a procedural language, that type of thing, rather than say, tell me everything you know about Java. Platform independence, that type of thing could be fair game. That would be more of a fair game question related to Java than, just tell me a blurb about Java. I would ask something a little more directed. Something on here could be fair game related to the platform independence, how the Java virtual machine functions in the world of the Java programming language. Comparing Java to the .NET languages, that could also be a fair game question. Java is platform independent on any platform that supports the Java virtual machine. This .NET languages is platform independent on all platforms as long as it's Windows. Could be something from the Microsoft story of how they kind of got into the Java world and ultimately C# was created. Again, I'd have to be running low on other questions. That's more of a connecting the dots between two endpoints. I care more about those endpoints than the details in between, although the details in between help us understand the endpoints better. Okay, so I would doubt I would ask questions about Microsoft stole Java and that kind of stuff. I wouldn't ask much about that story, I would guess. I wouldn't ask you to write any Java or C# code. We use that as examples to see where we're going, not related to what we really do in here. Would not probably ask you any C# specific questions, because I'm going to definitely have game salad specific questions. So figure half the questions in the test are probably going to be related directly to game salad. So I'm not going to have a whole lot of opportunity to ask you detailed questions about things like this. So the things that I will likely ask you about from our earlier slides are going to be more of the high-level big concepts. Procedural language versus object-oriented. I would be very surprised if that doesn't make it on there in some form. The way human beings solve problems. Again, I'd be very surprised if that doesn't make it on there in some form. Certainly something related to variables would be fair game. This falls into that category of how do human beings solve problems. So taking it to the next step of detail. Memory becomes variables. What do variables represent? Well, they're attributes in game salad, that kind of stuff. Two types of variables. Probably not really something I'd ask on this because it doesn't really translate well into game salad. It's there, but it's not really a clear distinction. So I probably would not ask something about our high-level language variables. Primitive types, I could ask something related to this. It would more than likely fall into the category of like converting a number or something like that. Showing me that you understand bits versus bytes and that kind of stuff, or maybe bases. Converting between a number in base 8 to a number in base 16 or something like that. Rather than, me asking, what's the smallest value that will fit inside of an int? I probably would not ask that question. This would be fair game, but I would doubt it's going to make the test. ASCII. Same thing with Unicode. I suppose I could ask the question, the difference between ASCII and Unicode, but I just don't think that'll make the test. Where ASCII, Unicode's a superset of ASCII. The first 256 characters of the Unicode character set is the ASCII character set, and then it fills in for the rest of the languages. Boolean expressions, fair game. Arithmetic operators, again, fair game, but that might fall into the category of me asking you to write a Boolean expression for something in game salad, something like that. I wouldn't ask you to write Java code in any form. I could ask you about Boolean logical operators. I wouldn't ask you to tell me what they are because these examples are the Java ones versus the game salad ones. But I might, for example, ask you something like, what's the difference between an and an or? Something like that. Have you tell me the difference between those two. So I wouldn't ask you about if statements specifically, but might ask you about rules related to game salad. So the if statement equivalent. So asking questions, that's the second way human beings solve problems. Certainly could ask you about double click to edit. So actors in game salad are equivalent to classes in Java. I might ask you to make that connection. Probably not. At that point, I'm probably going to be living directly in the game salad world. Certainly something related to blueprints of actors versus instances of actors in game salad. That understanding would be fair game. Threads could get on there. I wouldn't get real deep into them, but kind of threads related to timers, what a thread of execution really means. Concatenation, definitely fair game. Probably would not ask you anything about methods. We're kind of getting to where we're going to define our own behaviors in game salad. So that would probably be more of a fair gamey type thing on the final. So I wouldn't worry about it here. Iterative solutions versus recursive solutions. I could possibly see me asking something about recursion when something calls itself. I would still put it lower on the priority. So I would have to be getting desperate for questions. I know we're out of time, so let me just flip through real quick. Converting numbers, definitely. Arrays and tables, that connection, definitely. So this is where we ended up last time talking about tables. I probably would not ask you any API questions today, but I reserve the right to ask you those on the final. Okay, so everything before today would be possibly a free game for the fair game for the final, or the midterm rather. But I think I kind of went through there. I tried to stay on each slide, so if you go back through the video, you can read each slide and kind of see about that. But that should give you a pretty good idea for the test. Yep.
What's the format gonna be?
It'll be all written. No true false, no fill in the blank. It'll be, here's a question, give me your 2 or 3 sentence blurb answer. All right, I'll see everybody on Wednesday.